Good day, everyone. So I'm gonna show you how to create a linear power supply PCB using the EasyEDA Online device or online software. So after opening the EasyEDA and then you have logged in, so what you will do now is that you are going to create your schematic first. So you create a project. After creating the project, you will now have this default board, and then it will have the schematic and the PCB. So first we will have to add in the schematic. So to add in the schematic, right? So we have now our diode. So let's open our schematic, double click. Okay, so I'm going to place now our components. So there are, the good thing about your ECD is that it has, or there are stocks, or it is linked to the actual devices. So you are just going to search the devices that you wanted. So for example, I need to create now my input first. So my input is a KF301 connector. So let's just put in the keyword and then you just click, right? And then try to find the one that matches what you wanted. So this is what I want. This is the connector for my coming from my transformer. So I have going, or I will have now the V plus and V minus. So I'll just place it in, right? Okay, to zoom in, you just zoom or scroll your mouse. Now I wanted this to be to change, right? So that's it. So this is going to be my connector. So I'll just name this as J1. Now the next that I needed is my diode, so my rectified diode. So I'm going to add another one. So this is going to be my 1N5406. So let's just search. So again, it's important that you're actually going to see the correct footprint. So this is the one that I wanted. The footprint is a DO27. So I will just add it in. Okay. So I'm going to add four of this. So let's just change the orientation by using the space bar. So one, two, three, four. All right. So just press escape. Okay. So I actually there's a setting wherein it will automatically update, but anyway, let's just leave it as is. So for this one, I can already do my connection. So to connect, I'm going to use the wiring tool, right? So just simply connect the nodes as to how it is supposed to be connected. Okay, over here. All right. And then my V plus in is going to be at this node, and then the minus is going to be at this node. Okay. So when you see that there's dots there, it means that they or a connection was made. So you have to avoid that. So let's press this and let's try to move this here so that it will actually not interfere with the nodes. Okay. All right. So that is now my rectifier diode. So this time I'm going to create now my filter system. So I need a capacitor. So I'm going to place now my capacitor. Right. So for the capacitors, you can just filter it out. You place it here first. And then you just do the filter here. So for this one, I wanted it to be a through hole. So through hole, right? You type it in, you press that. Okay, the next is that I want it to be 10,000 microfarad, then probably 50 volts. So you just add the filters. Okay, so apply filters. Okay, so once it is there, you're just going to search the part, right? So since I'm not able to see the images, we can try, say for example, let's just change this one, 4,700 microfarad. Let's see if there is any available supply filter. Okay, so let's try this out. Let's see if this is the one that I want. Place. So I think it's pretty good. So I'll close it in. Okay. So like that. Right. And then I also need another one, but this time this is going to be a ceramic one. So not an electrolytic. So I know that that's an electrolytic because of that. Okay. So I'll just add another one, and this time it's going to be still through hole. Let's just leave that as is. Let's remove the filter here. Let's remove all of this. But this time I'm going to search for 100 nanofarad or zero point 0.1 microfarad. So apply filters. So I do have some options, right? So you will really see the actual. Okay, so what I wanted is kind of a ceramic, just a ceramic one. So let's try to um filter it some more. Okay, so let's see if I have anything here. Okay, so silicon, mica, tantalum. So let's try to see ceramic, capacitor. Okay, and then it's going to be, let's add it here, through hole. So I don't want it to be SMD. Okay, so light filters. So let's see if we can find anything. So this is a resistor, not a capacitor. Filters. Right. So let's do this again. Okay. So of course it will involve a lot of trial and error also. So the package I want it to be 3 volt. Right. So 3 volt. And let's see if I can find any. So multi-layer, not SMD. So I think this one should be good. Let's try it out. 100 nanofarad. Light filters. Let's see if we can find anything. Okay, no. So probably, let's see. Silicon capacitor. Through hole, this one. All right, so I think there is one there. Let's remove this and apply filters. No data. It's like this. Okay, so maybe we can try this one. Tantalum capacitors. Okay, so let's try that again. Okay, hold. Tantalum. Remove that. Apply filters. No data. Apply filters. Let's try it again. So let's have it. here, ceramic, hole, bipolar, ceramic capacitors. Yeah, so I think this should be which has a available here. So we can also even try to search. Okay, let's just do a through hole. Through hole. So I don't want any SMD. Apply filters. And let's try to find B. So I think we should be able to find a ceramic here. If you know the parts, then for sure. Okay, so I think this is what I wanted. So over this, okay, there's no part here. So let's continue the search. This should be also okay, but let me just continue the search. So we can, yeah, we can, yeah, no. So we don't have a part for that. Let's try to find another one. Okay, it might not be the most efficient, but so far it's the way that I know how. Right, so you can also open the data sheet just to see what to see. Right. So go back. Just see start. Okay. So we continue the search for the right capacitor. Right. So this one is. So it's actually I'm looking for the right footprint. So the footprint is what is much more important for me. So all right. So I think this one should be good. So this is the right footprint for me. So I'll just put this in. I'll place it inside. Right. And okay, so you can always change the value. So the value it's going to be, let's say the value of this one, it is going to be 100 millifarad. So that is what I want. Okay, now let's go back to our schematic. Okay, so I'm going to have now a an IC. So let's place here my LM317. So LM317. Again, it's important to find the correct footprint. So I wanted it to be the LM37 adjustable. But this is not the correct footprint that I wanted. You can always do a check as well. So for example, here it should be this one here, TO. All right. So I think this, any of this should do. So again, the important thing here for me is the pinouts are correct. And so let's choose this one. So let's place this. So let's have it like that. Now I have my LM. Right? So I have the input. So one thing that you have to ensure, right? And then I actually need another die, two more dies. So instead of getting from the place there, I'm just going to select Control C, Control V, Control P, Control V. Alright, copy. Hmm. This time I'm going to create, let me just set this here just for my connection to flip it horizontal. So input will be on. Let's do my connections first. Alright, so this one goes here on top. From here, goes here. From here, it goes here. And here, actually just for those connections. And then the output of this one goes with here. And we are also going to put a diode from the output and to the input. And so and just arrange it so it will be neater. And I'm going to add another one. But this time, this is from the just going to the so I will just make a connection now. And I want to add another 220. So the 220, I will have it as 220 resistor. So this is going to be the capacitors, and then I have to put the resistors, and it is going to be a through-hole resistor. Okay, so the through-hole resistor, it is resistance is still changing. Okay, so this one should be good. Place it, add it into my just connection again. This is how it's going to be connected. And then I also need a potentiometer. So this time I'll just add a It's a potentiometer. So this time it's going to be potentiometers. So this is a 5 kilo ohm. 5 kilo ohm. Reference, entrance is good. So that will determine the if it is a, and then I also want it to be full filters. Right, so these are examples of your um precision. So 3590. So let's try to see if we can find a 3590. So 3590x. So we have one that is available, so just place it. So this is our potentiometer. Remind that it is 10K. So again, what's important is the footprint. So let's just do it like this and do the connections. Make sure that it's properly connected. Done there, and then I'm going to get another capacitor. So this time it is a 10 microfarad. So let's go for it's another capacitor. So let's go to the capacitor. 10 microfarad. And glue hole. So let's okay. So I think this one should be good. Size is good. So just add it in. So this one should be connected in parallel to this one. Okay. And I'll have another 470 microfarad. So let's place another one. So this time it's going to be 470 microfarad. Hole. Apply filters. So this one, I'm happy with this also. I'm going to place it in. And this is going to be the bottom is missing. Okay. I also have another of this, so I'll just copy. Make this green. Paste. And then I'll have another um resistor. So it's 1K, so just around half watts of resistance. Let's just go back to resistors and then through hole resistors. I'll have it at 500 milliwatts. And okay, filters. Right, so this one should be good. Is it there? And I'll also include an LED. So have here. And let's see if I do have some um LED. Not an LED driver, but diode. Okay, displays. Let's do a search. LED. And make it through it. So this one should be good. So just place it there. Let's do the connection. Right. So we're almost there. What's missing now is our ground and our uh, connection to our ammeter display and voltage. Right. So I wanted to have this, so I'll copy. It's still going to be the same thing. So this is going to be my output, right? And I'm also going to have another of that for my ammeter. So I just did, so that is for my ammeter. So the connection is going to here, and then the connection of this one is going to this one here. So let's make sure that this is connected. And the output, that is by my output. This is also going to be connected here. And I'll have to have my 3-pin connector. So I'll just name this one. So I'll add one more for the ISO connectors, and then it's going to be let's try to see KF0301. Let's see if there's a 3-pin equivalent for that. Right, so there is actually one. So let's place it 3-pin and then do the connection. So one connection, supposed to go to the input. So one pin goes to the input. The other goes to ground and the other goes to the output. So this two goes to the ground. Here, number 3 goes to the. So the remaining thing that we have to do is ground. So let's see. I now have my power ground. So to separate them, right? So I have my power ground here. And I will also have another ground. So this is my output ground. All right, so we finished now our schematic diagram. Okay, so the next thing that we are going to do is to create now our PCB. So now that we have finished that, we're going to go to design and then we're going to convert schematic to PCB. Right? And since we fixed the footprints will now be added in. So apply changes. So this is now our, so I think we forgot to connect. All right, so this one we don't need this, so we just, so now we do have our connection. So what we'll do now is to fix what is the size of our board. So our board, we select that to get our board, click one side. Oh, before we do that, let's change the units first. So view, unit, and make it 2 mm. That's it. Click. So it's 100 plus tab by 50 millimeters. So that's how big our board should be. So you have to rearrange this and add it in so that it will fit our board. So what we'll do now is to let's just move this down first. So over here. Right. So select the components, add it in. Okay, you use the space bar to do the connections. Let's see, diode 1. So I have my diode 1 over here. So the good thing about this one, if you see the blue wire, it means that these are the connections in my schematic. So I'm going to just do that, or let's just make it into a kind of a diamond. So right click this one, I'll rotate by reference point. So basically now you are designing your, you are going to design now your PCB, right? So right click, rotate, reference point over here. So that should be -45. Let's see. Right, so let's fix this. So it should be like that. And we have to make sure that it is within the board or inside the board. Okay. Take the reference point, 45. Spread it again. Okay. So rearrange it so that it becomes, so remember that you can always put it in. So try to rearrange it so that it will align. And here, I think this one is not probably 45, so let's try that again. Rotate. And let's flip it. So 335. 335. Okay. So three. Okay. Now this next is our filter. So again, so we just simply rearrange it to the make a good path. So most likely this one around there, that will also be good. So let's also put this in here. Let's see if we can put it. All right, so it goes around here. Okay. Now for the diode. So there's a diode there. We can just add it here, I think. There's a path. Right? And we also have another diode. Let's see. So I think this is the vector. Let's move this up a bit. So it's basically just rearranging everything so that let's see. For our emitter. So this one we can leave it here. Emitter. Let's just put it into it and then we'll figure out the connections later. All right, so fix. So let's see. So what we'll do, we create our zone first, right? So this is going to be, okay, so let's, right, so that is 100 by 50. So our zone here, what we'll just do, it will fill the region, but we change it to be ground. So that is going to be our zone. And okay, right. So let's just confirm. Okay, that's going. So we the next thing that we'll do is that we have to make sure to make it. Oh, I think this one. Oops, sorry. Okay, so this. And delete that first so that it's easier for us to model. Okay. So next is that we are going to create an alert. So we'll click this one. Now the track width we have to set it at 5 kilometers. So you're just going to do the connection. So this is supposed to go there. So go here. And so what you'll do is to just basically create my nodes. So it's okay now. Let's just we will eventually edit and graphic. So you're just going to follow the wires, right? So for this one, you're supposed to create the ground is here, so you just go there, right? Or probably you don't. Let's put this just here and then here. So there is a connection here. So we'll see, right? And this one is supposed to, if there is a connection there, so probably have to move it around. Okay, let's delete this one first. Let's put this one here. Okay, it will still be writing statement to check later on. Submit, show it again, and again, make sure 1.5, see the connection again, put it on top. Maybe remove this a little inside so that there's more routes. So let's really try and error at this point. 5, try it again. So this one is gonna put here. And this is going to be connected to here. And here's the first one. So this is everything about this one. You will be guided as to what is the correct connection. Diagram. So oops. And then where there's going to be right. Continue this. Yeah.